15, find all the vertical asymptotes of the graph here. Okay, so we know that asymptotes occur whenever, let's see if I can zoom in here. Asymptotes occur whenever there are linear binomials in the denominator that will not cancel out. So we got an x minus 2. Now my guess is that that x minus 2 can cancel out. So, whoa, I got some cats. What's going on with those cats? Okay, I do not see what minus 2. Oh, okay. Now it looked like those two were going to cancel out, but they didn't. So therefore, it looks like it would be at positive 5 and negative 2 is where the vertical asymptotes are going to take place. So at 5 and negative 2. Okay, you feel like they were going to cancel, but they actually didn't. So that's why it's both of them. Okay, so now, but can you guys turn that down a little bit? Let's see, we have an original function. You plug in a 2, you get a 3. Then you add that derivative. At 2, you get negative 1. Find the equation of the tangent line when x equals 2. Okay, so this feels like a step backwards because we actually already have the derivative. We have the point. So what we're doing is we're interpreting the symbol system here, right? We're interpreting the grammar because we're interested in 2, and that is exactly where that is taking place. So if this would have said a 3, we're out of luck. We would not actually be able to complete the question. All right. So anyways, that means we have, if this is the x coordinate, that's the y, and then this guy is the m. So so we would have y minus 3 equals negative 1, and then x minus 2. Okay, and this is fine, although we can put the plus 3 over there to the other side. So it looks like plus 3 is right there. This is the guy. It's weird to see the negative 1 there, but that's correct. Okay, find the derivative. Here's just, wow, this is kind of easy. So let me just crank out this answer. Okay, so what's this guy? Minus 18x squared plus 2. They got the minus 2 there, so that's incorrect. All right, now here's one of the ones that you guys really didn't like this one because you didn't like having the fractional exponents. But what we want to do is we want to rewrite this guy. So before we take the derivative, let's rewrite this so that we actually get a polynomial kind of like this. So let's see if we can work this out here. I guess you could do the quotient rule, but I don't think that's going to work out for you. Let's try this. Let's go in the way that I think the AP exam would want you to take. So let's split that square root up, and we're going to do that. Okay. Okay. So we split up the square root of x over both terms. And so now we just turn it into a half. So what we can do now is we can say that this is x2 minus 1/2 is actually 1.5 minus 4, and then 1 minus 1/2 is just a half. Okay, and what we have here really is a polynomial, basically, because that's f of x. So f prime of x would equal 3 over 2 x minus 1/2 times 4 is 2, and then we're going to have x to the negative 1/2. Okay, because it'll drop a degree. Now, which one of these looks like that's the case? Well, let's see. We've got 3x over 2 minus 2, and then this guy is x to the 1/2. Okay, so this is what we got. He's going to need, let's see if we can create anything here. That's actually close to what we had, but it's actually minus 4. So I'm not, no. Oh wait, he didn't drop a degree. He's 1/2. Okay, so he's He's 1/2. So he's actually 1/2. Okay. So, okay. So now he needs to give this guy an x to the half. Okay. If we give him an x to the half, he needs a 2. Okay, so let's give them an x to the half. Okay. So now we can combine them. All right, there's our answer, A. Pretty tough stuff. This guy almost got by me. Okay, watch out for that. Or I'm really kind of talking to myself there. Maybe you guys saw it and were yelling at the screen. Good for you. Good job. But really, this is kind of the problem when you're dealing with problems like these, is finding the answer in the right form, because we could have stopped right there, right? If you wanted to plug in a number, it would work. But now there's kind of a series of algebraic mastery that you kind of have to show to get the answer. Even though you know how to do it, you kind of have to play some games there. Okay. So anyways, moving forward, where are we at? 6 minutes? Right. So this is just dy dx, and we've got some trig functions. That's not that big of a deal here. Cosine is negative sine, so that would be -5 sine. You don't have to worry about any chain rule at all, so that's nice. Then -3 cosine plus 4, so let's just see what we got here. Is that the guy? Yep, that's the guy. Okay, nice, nice. Okay. All right, I guess we'll... we can do another one here. Find the equation for the tangent line to the graph here of this quadratic at the point x equals 1. Okay, so at x equals 1, in order to find the tangent line, of course, you need a point. You need a point, and you need a slope. Okay, so let's get the point first. Let's plug in 1. Okay, so if we get f of 1, gives us... I could have used synthetic division for that, but 2 minus 2 is 0, 3. So it looks like my point is 1, 3. And then I have to find the derivative, which for a quadratic is super nice. So we get 4x minus 2. Okay, we're just using the power rules there. And so at 1, it looks like we would get 4 minus 2 is just going to be 2. So our slope then is we get y equals slope of 2, x minus 1 plus 3. Now notice that I did not put the minus 3 here. I already moved them to this side. So let's see if there's anything that looks like, nope, nothing. I do see this and this. So my guess is that they probably distributed the 2x minus 2 plus 3. And then those guys would combine to get positive 1. So it looks like it's not this guy, but this guy. Okay, nice. All right, one more for the road. That way we start off at an even number and probably finish this out by no, maybe not. What do we got? How many? 25? 20, no, 31. Okay. The position function, okay, great, and it's in feet per second, and find the velocity when the object is after 2 seconds. That's a piece of cake. I know I keep calling this a piece of cake. Sorry. All right, so I'm gonna go ahead and take the derivative of the position function so that I get the velocity function. I get 12t plus 240. Okay, great. Now to find the velocity, I'm just going to plug in a 2 into the derivative. Okay, so it's 240 plus 24. That's 264, and we want to make sure that that is feet per second. Right here. All right. Okay, so position, velocity, acceleration, they're really just the first and second derivatives. All right, stop there.